Hello everyone, welcome to Oil Gas YouTube channel, and this is our first lecture of Drilling Engineering 1. In this lecture we are going to discuss about the hydrostatic pressure of the liquid. So let's start the lecture. The hydrostatic pressure of a liquid is the pressure which is exerted by the vertical column of that liquid. Let I explain you with some example. In this container you can see that the container is filled with some liquid. If I consider this point A in the body of the liquid, then we know that the molecule which is present at that point is under the pressure of many molecules which are lying over it. So the pressure exerted by the series of molecule on that point A, on the molecule which is present on point A, is known as the hydrostatic pressure. So the total pressure which is exerted on a particular point in the body of the liquid due to the vertical column which is present above that point is called the hydrostatic pressure. So the hydrostatic pressure is simply the pressure which is exerted by the vertical column of the liquid. Now let us discuss that what is the relation of the hydrostatic pressure of liquid with the depth in the body of the liquid. The point which is necessary to remember is that the height or the depth h is always measured from the free surface of the liquid, from the surface of the liquid. In order to calculate the hydrostatic pressure, we always measure the value of h from the surface of the liquid. And then from this point that is lying on the surface of the liquid, we move down in the body of the liquid to calculate h. If we want to learn that what is the relation between the hydrostatic pressure and depth of the column of liquid, then the relation between the hydrostatic pressure and the depth of the liquid is direct relation. You can see here that the hydrostatic pressure which is exerted by the column of liquid is directly proportional to the depth of the liquid. Means the greater will be the depth of the liquid, will greater be the value of hydrostatic pressure of the liquid. For example, if this point, which is point 1, is lying 10 meters from the surface, and there is another point, say point 2, is lying 2 meters from the surface, then obviously the pressure at point 1 which is exerted by the column of liquid above it is very less than the pressure, hydrostatic pressure at point 2. So the hydrostatic pressure is directly dependent on the depth inside the body of the liquid. The greater will be the depth, will greater be the value of hydrostatic pressure. So this means that as we go down in the body of the liquid, the value of the hydrostatic pressure which is exerted by the column of liquid is continuously increased, and the logical reason behind it is that the number of molecules which are present above the point is increased. So this is the basic concept of hydrostatic pressure, that hydrostatic pressure is directly dependent on depth, and as we go down in the body of the liquid, the value of the hydrostatic pressure is continuously increased. Since when we replace the proportionality sign, then we must put some equals to and constant. So I put here is equals to and constant, and in this scenario the density of the liquid and the acceleration due to gravity is constant. So the formula becomes P is equals to rho gh, where P is the hydrostatic pressure, rho is the density of the liquid, g is the acceleration due to gravity, and h is the height of the liquid. So we can say that the hydrostatic pressure for a given liquid of particular density at given elevation, where the value of G is known, is dependent on the depth of the liquid. So basically the hydrostatic pressure is dependent on three parameters: density, gravitational acceleration, and depth in the body of the liquid. But usually the liquid density is constant throughout the experiment, or for which we are measuring the hydrostatic pressure, as well as the value of G is also remain constant throughout the experiment. So the pressure value, hydrostatic pressure value, is only dependent on the vertical depth inside the body of the liquid. So this is the basic concept of hydrostatic pressure. Here you can see that if we want to calculate the hydrostatic pressure at point A, then we must know that what is the depth of this point from the free surface of the liquid. Since in this scenario the depth of this point is h from the free surface of the liquid, therefore the hydrostatic pressure at point A can be calculated by P is equals to rho g h, where h represents the vertical depth from the surface of the liquid to point A. The point which is necessary to remember is that we always measure the vertical depth inside the body of the liquid, and it is always measured from the free surface. Here in this formula, G is representing the acceleration due to gravity, and its value, if we are working on standard unit, then its value will be meter per second square. H is representing the vertical depth of the column of liquid, and if we are working on SI system, then its unit is meter. Rho is representing the density of the liquid. In SI system, its unit is kilogram per meter cube, and the value of P, which is the hydrostatic pressure, uh, will comes out in pascals, which is the SI unit of pressure, or the value of 1 pascal is equals to 1 Newton per meter square. We can also represent pascals as Newton per meter square. Both are considered as the SI unit of pressure. So here we are going to do some numerical related to hydrostatic pressure. In this lecture, we are going to see only one numerical, whereas we will do some further numericals in the coming lectures. So the numerical is saying to calculate the hydrostatic pressure of water which is present at 4 degrees centigrade at 10 meter and 20 meters. So we have to calculate the hydrostatic pressure of water when the depth is 10 meter and the depth is 20 meters. So we have to calculate the hydrostatic pressure at these two depths. Since we know that the hydrostatic pressure can be calculated by rho gh, at 4 degrees centigrade, the density value of water is 1000. So in place of rho, we put 1000. The value of G is 9.8, and the value of depth in part 1 is 10. So the answer becomes 980,000 pascals. So this is the value of hydrostatic pressure at 10 meters. Now we will calculate the hydrostatic pressure at 20 meters. So pressure at 20 meters, since the fluid is again water, so the density remains 1,000 kilogram per meter cube. Value of G remains 9.8, and the depth value is now 20 meters, which is double of 10. So 9.8 multiplied by 20 multiplied by 1000, the answer is 196,000 pascals. So this is the value of hydrostatic pressure. These are the values of hydrostatic pressure at 10 meters and 20 meters. So every particle, every molecule of liquid which is present at 10 meter depth is experiencing 98,000 pascals pressure, whereas every particle of the liquid which is present at the depth of 20 meter is experiencing 196,000 pascals pressure. So this is the simple numerical of hydrostatic pressure. So if we want to compare these two pressures, oh sorry, here I put 10 extra. So if we want to compare the two pressures, then 196,000 divided by 98,000, so the answer is 2. So we can see that the hydrostatic pressure at 20 meters is double than the hydrostatic pressure at 10 meters. So it is proved that when the depth inside the body of liquid is doubled, then the hydrostatic pressure will also double. So hydrostatic pressure is directly depending on the depth inside the body of the liquid, and when we double the depth inside the body of the liquid, the hydrostatic pressure also becomes double. When we half the depth of the liquid, the hydrostatic pressure is also halved. So the hydrostatic pressure is directly dependent on the depth inside the body of the liquid. So we will do some more numericals in the coming videos. Keep watching the videos and keep in touch, so you will get more interesting concepts related to drilling engineering. Thank you.